Hello and welcome back. This is part two of simplifying radical expressions. I didn't quite get to go through all the examples that I wanted to show you. We already covered this example here, talking about the product of powers rule where we add these guys, and I wanted to cover these examples. So again, these are just variables. Here I am dividing two variables with the same base. So if I have the same base, I can subtract their exponent. So I'm going to subtract 5/3, take away 3/4. Notice I can't subtract them because they don't have a common denominator, so I'm going to make them have a common denominator. And 3 and 4, I think the lowest common denominator would be 12. To get 3 to be 12, we'd multiply by 4. So 4 times 5 is 20, minus 4 to 12, that's multiplying by 3. So 3 times 3 is 9. And 20, take away 9. Let me put my equal signs here. Equals gives us x to the 11th over 12th power. So that is the answer for this example. The next one that we have here is just power of a power rule. So I have x, and I'm going to go ahead and distribute this. So I have 5/3 multiplying times 1/5. 5 times 1 is 5. 3 times 5 is 15. And 5/15 reduces to 1/3. So I have x to the 1/3 power, or the cube root, right, of x. Again, I have some practice problems here. Go ahead and please practice these on your whiteboard and then unpause the video when you have done this. Okay, hopefully you have tried these practice problems. The first one, you get a solution like this. Same base, add the exponents. Here we are dividing the same base, so we subtract the exponents, and we have to get common denominators. Also here, please remember to reduce too on this example. So 36 over 24, that reduces to y to the 3/2. So make sure you reduce there. And then here, power to a power, we're just going to go ahead and multiply. 4 times 5 is 20. And 6 times 3 gives us 18. 20 over 18 reduces to 10/9. Okay. And the last two examples for your notes. These last two examples are pretty gnarly, but we're just going to keep it simple and just go through our normal procedures. So here I have a power to a power, so I'm going to get y, and I just multiply my powers. So 4 times 3 gives me 12. 3 times 2 gives me 6. So I have that on top. On the bottom, I have really here I'm multiplying two things. And if you look back at your notes, we have when I have a product like this, I distribute that power into each one. So I'm going to have 16 to the 3/2 power times y to the 2/3 times 3/2. Well, when I multiply these, right, 2 times 3 gives me 6. So 6, and 3 times 2 gives me 6. So these really reduce, and this top one reduces too. So y to the 2nd power divided by, I'm going to keep this guy kind of like this. So 16 square root of 16 to the 3rd power, and y to the 6 over 6. Well, this is just 1. So here I have this guy, and when I do this y cancels out with 1y here. So I have y over, well, the square root of 16 is 4 cubed, and this works out to be y over 64. So lots of steps here. Just remember your basic algebraic kind of principles and the new properties that we've worked with, and everything kind of works out. The next problem, I believe this is the last example that I have for you. I'm going to distribute my 2/3 in, so 27 to the power of 2/3 times x to the power of 3/4, and I'm going to distribute that 2/3 in. So 3 times 2 is 6, and the denominator I get 4 times 3, which is 12. So this reduces, and I get the cubic root of 27 squared times x to the power of 6 over 12, which is x to the 1/2 power. Cubic root of 27 is 3 squared times x to the power of 1/2, and this gives me 9 times x to the power of 1/2, or the square root of x. Kind of simplified. You can see it like this. Okay, those are the final examples. I do have a couple of practice problems for you, so please go ahead and pause the video and try these examples. If you tried these, you should have gotten a solution similar to this. Not similar, exactly like this. And here for this guy. So same principles as the problem that we just did. For your closure, the closure is saying how is simplifying the square root of 24 different from simplifying the cubic root of 24. So please go ahead and think about this for a second and respond. And if we're thinking about this, in order to simplify the square root of 24, we have to go ahead and identify, are there any perfect squares in here, right? 24 is not a perfect square, so I pull that 4 out. I'm going to split 24 into 4 times 6, and when I do this, I can take the square root of 4, so this becomes 2 root 6, right? This becomes 2 root 6. For the cubic root of 24, you want to kind of isolate a perfect cube in there, and that's 8 times 3, right? And I can take the cubic root of 8, so this would become 2 root 3. Okay? Like my videos, subscribe, do all that awesome stuff. I'll see you tomorrow. Don't forget to do the independent practice. Do tomorrow. All right? Deuces.